Introduction. Hi Aarti, can you help me solving this question?
Yes, tell me what is the problem?
I have to find the area of this triangle.
Oh, it's easy. We can calculate its area by using Heron's formula.
Heron's formula?
Yes, Heron's formula. We use this formula to find the area of triangle when the height of the triangle is not given. Come, I will tell you more about Heron's formula.
Objectives. At the end of this lesson, you'll be able to define Heron's formula, write the formula for Heron's formula, find the area of a triangle by Heron's formula, find the area of quadrilaterals using Heron's formula. Definition. Heron's formula is named after Heron of Alexandria, a Greek engineer and mathematician in 10 AD to 75 AD. We can use this formula to find the area of a triangle using the three side lengths. The formula given by Heron about the area of a triangle is also known as Heron's formula. Formula. We do not have to rely on the formula for area that uses base and height. The figure illustrates the general formula where S represents the semi-perimeter of the triangle. We just have to use two-step process. Step 1. Calculate S, half of the triangle's perimeter, using S is equal to A plus B plus C whole upon 2. And step 2. Then calculate the area using A is equal to square root S into S minus A into S minus B into S minus C, where A, B and C are the sides of the triangle. Example. Let us look at some solved examples now. Use Heron's formula to find the area of triangle ABC if side AB is 3, BC is 2 and CA is 4. Solution. We will find the area step by step. Step 1. Calculate the semi-perimeter S, which is equal to A plus B plus C upon 2. By substituting the values of sides we get S is equal to 3 plus 2 plus 4 whole upon 2. And by solving this we get S as 4.5. Step 2. By substitute S into the formula, A is equal to square root S into S minus A, S minus B, S minus C. We get A is equal to square root 4.5 into 4.5 minus 2 into 4.5 minus 3 into 4.5 minus 4. By calculating it, we get A is equal to square root 8.4375, which is approximately equal to 2.9. Given a triangle with an area of 8.94 square units, a perimeter of 16, and side lengths AB is equal to 3 and CA is equal to 7, what is the length of side BC? Solution. Step 1. Calculate the semi-perimeter S, which is equal to perimeter upon 2. Here perimeter given is 16. Therefore, S is 16 upon 2, which is 8. Step 2. Substitute the known values into this formula. A is equal to square root S into S minus A into S minus B into S minus C. Since the value of BC is not given, let X be the length BC. Therefore, by substituting the values we get 8.94 equals to square root 8 into 8 minus 3 into 8 minus X into 8 minus 7. Now solve for X by squaring both sides. We get 8.94 square equals to square root 8 into 8 minus 3 into 8 minus X into 8 minus 7 whole square. By calculating it, we get x is approximately equal to 6.0. Applications of Heron's formula in finding area of a quadrilateral. Heron's formula is also used to find the area of a quadrilateral if all its sides are given. For that, we divide the quadrilateral into triangular parts and then find its area. Let us look at some examples. If one of those triangles is a right-angled triangle, Pythagoras' rule can be used to find the length of the diagonal. Let us go through some examples. Find the area of quadrilateral ABCD, in which AB is equal to 7 cm, BC equals 6 cm, CD equals 12 cm, DA equals 15 cm, and AC is equal to 9 cm. Look at this quadrilateral. To find its area, we divide it into two triangles. Let's now find the area of these triangles one by one. For triangle ABC, S is equal to A plus B plus C whole upon 2, which is equal to 6 plus 7 plus 9 whole upon 2, which equals 22 upon 2, which is 11 cm. Now, by Heron's formula, area is equal to square root S into S minus A into S minus B into S minus C. By substituting the values in the formula, we get area of triangle ABC is equal to square root 11 into 5 into 4 into 2, which implies area of triangle ABC is equal to square root 440, which is 20.98 centimeters square. Now for triangle ACD, S is equal to 9 plus 12 plus 15 upon 2 is equal to 18 centimeter. By Heron's formula, area is equal to square root S into S minus A into S minus B into S minus C. Therefore, area of triangle ACD is equal to square root 18 into 9 into 6 into 3. By solving it, we get area of triangle ACD is 54 centimeters square. Hence, the area of quadrilateral ABCD is equal to area of triangle ABC plus area of triangle ACD, which is 20.98 plus 54. Therefore, area of quadrilateral is equal to 74.98 centimeters square. Did you know? Heron was born in about 10 AD, possibly in Alexandria in Egypt. He worked in applied mathematics. His geometrical works deal largely with problems on mensuration written in 3 books. In the book, Heron has derived the famous formula for the area of a triangle in terms of its 3 sides. Summary. Let us summarize what we have learned. Areas of a triangle with its sides as A, B and C is calculated by using Heron's formula, stated as: Heron's formula can be used to find the area of irregular quadrilateral if its all sides are given. For that, we can convert that quadrilateral into triangles and then apply Heron's formula.